Let's start with the basic example of a gradient descent, and for that I'll create a file over here that is gradient.py, and here we'll start with importing the basic library, starting with import of math. Then comes the next value, that is import matplotlib .pyplot. This is also other way to do it, as plt. And then comes the functional tools, because we are including functions of partial. If you know the basic analysis of Python, we have partial for the mathematical calculations. Import partial. Now after this, we'll call for the difference quotient, the function which we declared in our last chapter while introducing for the gradient descent. So that I'll say def difference quotient as with the parameter of f, x, h, and the next parameter will be returning a value, that is return f of x plus h minus f of x. So this is giving a difference between the values of the functions divided by h, which will be the interval. After this, we need to have a square and derivative declared over here. So that will be given as definition square of x, which will return a value, return square will return product of the same number twice. And for the derivative, I will give a value, that is df derivative value as x will be given as return, it will return twice of that particular number. And after that comes the derivative estimate to be calculated. So my derivative estimate will be calculated as partial of that particular function. So it will be derivative underscore estimate equals partial of difference quotient comma square of particular value where h equals 0.0001, and then I'll just calculate the range as x equals range of minus 10 of 10, and then comes the title of the particular thing. So my title is to calculate the derivatives versus estimate, so it will be given as plt.title. The title is nothing but actual derivatives versus estimates. So once this title has been calculated, the next thing we need to do is to plot the graph. So that is plt.plot with the value as x, map derivative. It will map the derivative with x value, and then it will be taken with a parameter, that is the value for color, that is rx, and then comes the value for label as label equals actual. So we are specifying the color as red, and then we'll plot this value. So it will be plt.plot. Since we are plotting two values, so that is x, map, and this map will be nothing but derivative again with the same value, but it will calculate for derivative estimate and x with the color as blue. So blue color will be given as B plus, and then comes the label to be done as label. So here the label will be taken in this format, label as actual, and in the same way label here will be estimate. Now after this, I'll plot the legend value, that is plt.legend with the value as LOC equals 9, which is the local value format as 9. Now let's show this value, that is plt.show. So this section is being done. Now we'll go to the command prompt and just clear up these values and run the particular gradient value. So I'll run the gradient over here as Python gradient.py. So this gives the actual plotting of the actual derivatives versus estimates within plotting a particular value. So this is actually calculating the line of best fit and getting everything scattered within the single line, with the plus and into being like it is matching over in the same line. So that is why we are getting this particular path. So this is the gradient descent which has been calculated using Python and which is visible in your screen.